Hello, this seminar focuses on AutoMesh, which is one of many ways to generate a mesh in RecurDyn. AutoMesh is a function that automatically generates meshes without deep skills and knowledge about meshing. So, even beginners can use it easily. RecurDyn's AutoMesh provides many options. So, if you understand how to use them, you can create higher quality mesh too. In this seminar, I will explain the AutoMesh options one by one. I will try to explain them simply and intuitively, rather than explaining the exact algorithm or definition. This seminar has 4 parts. Before I start explaining the options of AutoMesh, I want to give you some background about meshing in RecurDyn. There are 3 kinds of meshes in RecurDyn: beam mesh, shell mesh, solid mesh. First, beam meshes. Beam meshes are generated from a curve, and they are composed of beam elements. Second, shell meshes. A shell mesh is generated from a surface. The mesh will consist of shell elements, so it doesn't fill volumes. It is also possible to generate a shell mesh from outer surfaces of a solid. If a shell mesh is generated from a solid shape, then the interior of the geometry will be empty. There will not be any mesh elements inside it. Third, solid meshes. A solid mesh is a mesh consists of 3D solid elements. Solid meshes fill the volumes of geometry with elements. This is the process that RecurDyn uses to create a solid mesh. When a solid mesh is generated in RecurDyn, RecurDyn first creates a shell mesh from the surface of the geometry. Then, a solid mesh is created from the shell mesh. In other words, when a user creates a solid mesh, a shell mesh is created during the process. So, if there is CAD geometry like this, the outside of the geometry is meshed as a shell mesh first. Then, the interior of the shell mesh is meshed as solid mesh. Now, I will explain the basic options of RecurDyn's AutoMesh. This is the dialog box for AutoMesh. This opens when you start AutoMesh. At the top is the target geometry. This is the geometry that is going to be meshed. You can select a curve, a surface, or a solid. The next option is Use Current Shell Mesh Info. This option is only enabled when the target geometry is already meshed as a shell mesh, and it can only be used if the mesh type is a solid element type. In other words, if a solid geometry is selected and shell mesh is created, then the option Use Current Shell Mesh Info is activated. I said before that when creating a solid mesh, a shell mesh is created internally in RecurDyn first. This option is used when you want to create solid mesh using shell mesh that you created explicitly. It means you can create higher quality solid mesh if you can create a higher quality shell mesh first. So, this option is somewhat like a manual mesh option. Take a look at this video. First, you need to generate a shell mesh from a solid geometry. Then, this option is activated and you need to select solid mesh type. Then you can create solid mesh from the shell mesh. Mesh type designates an element type to be used for a mesh. You can choose one out of 6 types of elements. But please note that the mesh that is generated might also include other types of elements in addition to the element types you selected. Property is used to set the property element that the mesh will use. A property element includes additional information about the mesh elements, like the thickness of shell elements. Beam, shell, and solid use different types of properties, and you can create and use a property element in advance. The next options are max element size and minimum element size. This term means these are important options. They specify the size of the elements that are generated. The size of the element means the length of the edge of an element, as shown in this figure. This edge is also called a line. Please note that the initial value is calculated to be 2.5% of the diagonal length of the target geometry. And also note that some elements of the mesh can be smaller or bigger than the specified size. As shown in the image of the two circles at the bottom of the slide, larger values of the max and min values cause the generated elements to become larger, like this. The next option is the Chordal error ratio. The Chordal error ratio is an option that controls the error between the actual CAD shape and the mesh in area of the geometry that are curved. Small values cause the mesher to generate smaller elements. So, smaller values cause the mesh to match the original geometry better. The example here shows that if a smaller value is used for the Chordal error ratio, then the mesh matches the shape of the protruding bump better, like this. Structured output is an option that controls the pattern of the elements that are generated. You can see the difference in the element patterns of the three meshes. The left one is the default pattern that is used when the structured output is left unchecked. The middle one is the simple pattern, and the right one is the Union Jack pattern. The Union Jack pattern is named after the flag of the United Kingdom. In most cases, the default setting is reasonable, but sometimes the other two options can provide better results. Closed gaps is an option that is seldom used. In rare cases, the CAD data has some errors. As shown in the image, the vertex should be touching the left edge, but the CAD data can have an error in it. There can be a very small gap between the edge and the vertex, like this. This error might be invisible. If nothing special is done, the mesher can generate a very strange mesh in this area. The closed gaps option is designed to solve these errors. Closed gaps causes the mesher to treat small gaps as though those parts of the mesh were connected. Weight on quadrangles is an option available only when shell4 is selected as the mesh type. This option tells the mesher the priority to use shell4 elements. When shell4 is selected as the mesh type, the mesher can also use shell3 elements. High means high priority to use shell4. Low means it is okay to use more shell3 elements. In other words, weight on quadrangles can force the mesher to create more shell4 and fewer shell3 elements. Note that the UI in RecurDyn V9R4 has changed. This is an image of the V9R3 dialog box. Include Assist Modeling is an option that determines if the assist modeling settings are used by the mesher when creating a mesh. The geometry that is converted to a flexible body by the mesher can be a rigid body that is already part of a RecurDyn model. The body can have joints, force elements, and contacts attached to it already. The mesher has the ability to preserve those elements. If the elements are preserved, then after meshing, the newly created flexible body will still have these elements connected to it. Assist modeling is the settings for which elements to preserve when meshing it. If include assist modeling is used, then the mesher will preserve the elements that were selected in the assist modeling dialog box. If include assist modeling is not used, then the mesher will remove all elements from the body after meshing it. Usually, in most cases, this option is used if assist modeling is used. This option is new in RecurDyn V9R4. Auto Flex Merge. If this option is used, Flex Merge is automatically performed when creating a mesh. This option is required when meshing a body that contains two or more geometries. If there are faces in the geometry that are in contact with each other, turn on Auto Flex Merge. Then the touching faces share the nodes. Like this. It means two geometries are treated as one mesh. The top image is a mesh created with the option turned off, and you can see that the nodes on the touching faces are misaligned. It means the mesh above and the mesh below the face are separate. The image below is a mesh created with the option turned on, and the nodes on the touching faces are treated as coincident. It means the upper part and the lower part are treated as one mesh. RecurDyn will show a message that indicates that 17 nodes were processed as coincident. In V9R3, Flex Merge required manual operation, but starting with V9R4, it can be performed automatically using this option. Create beam element with pre-stress. This option determines the undeformed shape of the beam. If create beam element with pre-stress is off, then the shape of the geometry is the undeformed shape of the mesh. So, if no force is applied to the mesh, then it will stay in that shape. If create beam element with pre-stress is on, then the undeformed shape of the mesh is a straight line. Even if no external force is applied, the mesh will have a restoring force that tries to return it to a straight line. The video demonstrates this. There are three buttons at the bottom of the dialog box. The revert button returns the mesh to the state before the mesh was created. This is like undo. It undoes the mesh operation. The mesh button executes the mesher, and the cancel button closes the dialog box without executing the mesher. Now, let me explain the additional options. These additional options can be changed through the sub-dialog box that pops up by clicking this additional options button. Some of the options shown here are also supported in RecurDyn V9R3, but most were added in RecurDyn V9R4. The first additional mesh option is the optimization level. This option controls the quality of the mesh. Low means prioritize the mesh creation speed, and high means prioritize the quality of the mesh. As shown in the example below, if high option is used, the aspect ratios of the elements become smaller, 144 to 42. But the mesh creation speed can be slow if you use high option. The next option is the gradation factor. Here, the options in the shell option group are those that affect a shell mesh. However, as I said before, these options affect a shell mesh that is used when creating a solid mesh too. The gradation factor defines the rate at which the mesh transitions between high mesh density and low mesh density. A smaller value causes the element size to vary more slowly. A larger gradation factor causes the element size to vary more quickly. This can decrease the total number of elements. In the case of the example at the bottom, if the deformation or stress of the inner part is not important, then using the value of 2.0 might be better than this one. Internal element size is an option to define the size of the element located inside the geometry. Larger value cause the internal elements to be meshed larger. Larger elements means fewer elements. If the deformation in the interior of the body is not significant, then larger elements can reduce the simulation time. This is the option we use for such cases. Internal element size can be set independently for shell options and for solid option. As you can see, using larger element size can reduce the number of elements. The facet angle tolerance option controls the angle between adjacent elements. Small values cause the angles differences between neighboring elements to be small. Large values allows for the elements to have larger angular differences from their neighboring elements. Take a look at this table. If this value is small, the shape of the mesh is close to the original shape of the geometry. The number of elements increases, but the mesh quality can be worse. On the other hand, if this value is big, the shape of the mesh can be different from the original shape. Look at the hole in this body, but the mesh quality can be better and number of elements can be smaller. This option only affects shell meshes. And as shown in this image, only holes with smooth outlines are affected by this option. Polygons are not affected. This option limits the range of the numbers of elements created around these holes or closed curves on a surface. If you set the minimum value to 7 and the maximum value to 8, as you can see, the number of elements created around each hole is within that range. 7, 8. This option is usually used when you want to create a large number of elements around the hole. Depth values 7 and 8 are used here just to illustrate the meaning. Usually, much bigger values than 7 or 8 are used for this option. However, this option is also affected by element size. This option will not be applied if the max element size or facet angle tolerance is too small for a given hole. In this image, 4 and 5 were used as this option, but a much greater number of elements were created around the hole. If the user really wanted to create between 4 to 5 elements around the hole, then the size of the element would have to be about 100, because the diameter of this hole is 200. But since max element size is 10, the Mesher ignores the min and max number of edges along loops. The name of this option is a bit vague. Force the number of lines in edges to be even. It means force the number of element edges generated on a CAD geometry edge to be even. This is an option to generate an even number of lines of elements on the edge of a CAD geometry. From this to this, 7 to 8. In other words, the number of nodes on the edge of the CAD geometry become odd. 1, 2, 3, 4, 5, 6, 7, 8, 9. If this option is used, the elements on the edge are likely to be located uniformly or symmetrically. But since this is AutoMesh, it is not guaranteed. To create a symmetric mesh or uniform mesh correctly, you need to use a manual mesh with an option such as imprint. This option, Triangle, triangle, and quad junction only is available only when solid 8 element is selected as the mesh type. Usually, it is advantageous in a simulation to arrange the elements so that the same element types are side by side, triangle to triangle or quad to quad. But to satisfy that kind of condition, the number of elements can increase. In addition, it can increase the portion of elements with triangular faces, such as solid 4 and solid 5. So, to reduce the total number of elements and the number of solid 4 and solid 5 elements, it is recommended to set this option to off. So as you can see, when you use the option off, the total number of elements has reduced and the portion of solid 4 and solid 5 elements have reduced. Auto Cleanup Shell Mesh is very useful option supported starting in RecurDyn V9R4. I mentioned that when creating a solid mesh, a shell mesh is internally created first. However, during this process, errors such as free line, T-connection line, intersection line can occur in the shell mesh. In these cases, this error message is displayed. In previous versions of RecurDyn up to V9R3, in order to resolve this error, user had to create shell mesh and correct the error manually. Then you had to create solid mesh using the option Use Current Shell Mesh Info. In RecurDyn V9R4, this process is automatically performed. If this error message is displayed, you just turn on this option and click Mesh button again. Up to this point, I have introduced the basic options and the additional options. Before I finish this seminar, I'd like to introduce some tips for using AutoMesh options effectively. I have introduced various AutoMesh options, but among them, I listed the options that may be particularly useful. Understanding these options in particular first can help you to create better meshes. The Additional Mesh Options dialog box is a sub-dialog box that is opened from the Mesh dialog box. After you modify any option in this dialog box, you don't need to close it before clicking Mesh button. Even if Additional Mesh Options dialog box is open, the modified options are used when you click Mesh button. You can just click Mesh button. Then the additional mesh options can be used. Therefore, you do not need to open and close the sub-dialog box every time to modify the additional options. The best way to understand the AutoMesh options is to try them yourself. With a simple geometry, try the mesh options yourself and see the effects that they have. If you have any questions about the mesh option, please post a question on the FunctionBay technical site or send us an email. FunctionBay will do its best to answer your questions. Thank you for listening.